Hello everyone and welcome to Grantham Physics 221 Week 6 Lab 6. So this is a wave function and its probability again due at the end of the week. Um, Again, please remember to follow the lab write-up format and answer all the questions accordingly. So the key part of this week is looking at wave functions and what they mean. We're getting into quantum mechanics, all those different applications, Schrodinger's equation, so on and so forth. And one of them of interest is what's called a wave function. There's various situations. Some of the wave functions become very difficult to work with. Um, the hydrogen atom is one of the nice ones. It's completely solvable. It's a little beyond what we're going to do in here, but the one I've actually shown here is for what's called a finite square well. Okay. So again, the wave function is used to determine various properties in physics. One of them is the probability where a particle, usually an electron, is at one point in time. So this is the wave function for an infinite square well, and it's given as, notice it's a function of n and x. It's a square root of 2 over L sine n pi x over L, where L is the width of the well, x is the position, and n is the integer order of the wave function. Since it's a finite well, and it has to be like a standing wave, there are n numbers of nodes in this situation. So what I would like you to do is plot this wave function and also psi squared for n equals 1, 2, and 3, and see if there's a correlation between the values. Then ask is there any point where they connect. A point of construction, again you're going to use Excel to make these plots, and for simplicity let L equal 1 for the distance, and then you're going to let x run from 0 to 1 in steps of 0.05. That gives you a smoothness enough to this that you can actually see what's going on. So let's go over to Excel, and actually let's go over to the lab answer sheet first. So you notice here all we're looking for is a graph of psi squared, and then you're supposed to also explain where they connect and what the point of this is. So let's actually go over and look at Excel a little bit. So what I have here to start is I just have the x, I have the 0.5 all the way up, and I'm actually going to work through this one kind of for the lowest case since I can't really change the wave function too easily. So the first thing we want is our psi, psi of x, and we're going to put this in, and this will be for n equal to 1. Okay, so let's see what this is going to look like. So we see psi is the square root of 2, because it's square root of 2 over L, times the psi of pi times a2. Okay, so I put this in. I'm going to fill my values, copy cells. Okay, and then we have psi of x squared, and this easiest to think of is this value squared. So now I'm going to fill this in, the cells, and what you want to do then is make a graph of all three of these. Easiest way to do that is if you highlight this, it's going to put this as the x, which is nice because it's x, and that's going to then put these together. Again, you always do a scatter, and what I'm going to suggest here is just to do a nice smooth plot like this. Okay. Again, you want to modify the graph for an axis. Really here, you really don't want to go beyond 1. I don't even know why they would even do that. And then notice it maxes at around 2. So you're going to want to put that in at 2 here. And what you're looking for is where is their connection? How do these compare to each other? Now, I'll be 100% honest. For the first one, it's maybe not as straightforward as it is for some of the others. So when you sit down and work through these, you can actually figure these out really quick. Again, you can label these, change what the graphs look like, and so on and so forth. But this should start to give you a good understanding of what the wave function is and how it's important in physics. So now you may want to wonder how we're going to carry this on for the other n values that we need to do for this exercise. So what you would want to work with now, if you worked with the same numbers, let's say just PSI2 for example, is you're going to want to look at this equation. And remember that it's the square root 2 over L is the same, but there's an n in there. I know it's assigned n pi x over L. And the equation I just had pi, I set L equal to 1, so we don't have to worry about that. And then I had the x was the iteration. So if I move over here, I can take and just copy this. You have to kind of hit escape. It's kind of interesting how you have to do that. And you put 2 in here and times this. So when I copy this down now, I get these values. And if I get psi 2 squared, of course it's just going to be this squared. We get these values. Let me move my graph over here. And then I could then look at what these might look like. You can always hit control and that will ignore the others. Let's move them like this. You get a better idea how they start to pan out for the different values. So, again, remember what the importance of psi versus psi squared are here. Remember how you're looking for points of connection. You can examine the graphs and things like this. And remember how these tie into what are called physical observables and actual values in quantum mechanics. Again, please always remember to use the correct lab format with the reports. If you have any questions at any time, please send your instructor an email and they will get back to you as soon as possible. Hope you enjoyed the week and hope to see you in week 7.